So we were asked to factor these problems. And when we're asked to factor, the first step, of course, is always to look for the greatest common factor. So for number 1 here, we're looking for a greatest common factor between those two terms. 72 x to the 4th y and 48 x squared y squared. Now we can look for, when we do greatest common factor, we can look for the greatest common factor of the numbers. Now a factor is always smaller than the numbers, and it divides into those numbers. So what we're looking for is going to be smaller than either 72 or 48. And it'll go into both 72 and 48. We could factor and take all of the common factors. Did anybody find the greatest common factor as a number for 72 and 48? 24 is perfect. And then for the variables, if you remember, it is the lowest power of the variable. So for x, it's going to be what? X squared. And for y? Just y. So now we've got to divide to see what's left over. So 72 divided by 24 is 3. X to the 4th divided by x squared. X squared, and then of course the y's divide out. Negative 48 divided by 24 is negative 2. X squared divided by x squared cancels out. And y squared divided by y is just y. So we've got 24 x squared y times 3x squared minus 2y. For number 2 over here, is there a common factor? Well, this, you can think of that as being the number 1, so there's no numbers that divide out. I've got x and 2 of them, but you got to have the variable has to appear in every digit to be a common factor, so we can't divide out x's. So if we don't have a common factor, what do we try? That reverse multiplication, or FOIL in reverse. So it's going to split into two-digit numbers, or 2 binomials is the technical term for them. These first digits are going to be what? X and x, good. These last 2 digits have to multiply to make the 20. And then, of course, they're going to have to add up to the 9x if we do the check on them. So 20 could be 1 and 20, 2 and 10, 4 and 5. Do we know whether they're positive or negative here? Yeah, this is positive here, so they're either both positive or both negative. Because this is positive, we're pretty sure they're both positive. So what are we going to use? 4 and 5, okay. Now to be sure, we double check. Remember, we're doing FOIL in reverse. We've done the first and the last. We have to do the outside and the inside. On the outside, we have x times 5 is 5x. On the inside, we have 4 times x is 4x. That adds up to 9x. So that is what we wanted. So x squared plus 9x plus 20 factors out to be x plus 4 times x plus 5. Any questions on those first two? How many of you had the first two both right? Good. Pretty good turnout. Now, for number 3, a lot of people see 3 digits. Oops. Is there a question? Want to go back up for a second? For number 3, a lot of people want to jump, since it's 3 digits, into going to that reverse multiplication. But remember, we always have to start out with greatest common factor. And there is here. All those numbers can be divided by 5. And there is an x in every number. The lowest power is just x to the 1, or just x. So I have to divide each term by 5x. 5x to the 3rd divided by 5x is x squared. Negative 10x squared divided by 5x is a negative 2x. And negative 120x divided by 5x is a negative 24. We cannot assume we're done here yet. We've got to see if we can split this up further. Now the 5x would still be there if we can do that. So we're going to use that reverse multiplication on that. So we've got x and x make x squared. It's a negative 24, so we know one's going to be positive and one's going to be negative. Could be 1 times 24, 2 times 12, 3 times 8, or 4 times 6. Which one do we want to try? Plus 4 and minus 6. And of course, we need to get that to come out to a negative 2x. So let's check and see if we do. On the outside, we've got x times negative 6 is negative 6x. On the inside, we've got 4 times x, which is positive 4x. And that does add up to a negative 2x. So that is our factoring. So we had to do 2 steps to factor that one. Back up to number 4 here. No common factors there because we've got 1s and 1s and there's no x here. So it's just going to be reverse multiplication. So x times x to make x squared. Stay there. How about to make the negative 12? It's negative, so one's positive and one's negative. This is negative as well, which means that the negative 1 is probably larger. So you get plus 3 and minus 4. Any questions on those? Okay, so that's factoring. Today, we're going to take a little bit different look. Remember, we said that the purpose of that factoring is if we ran into an equation like this, to solve that, we can't just take it apart like we have been. We've looked at just seeing what's been done to the variable and then taking it apart. To make that work, though, we had to, one of the things I stressed, we had to make sure that we were down to seeing the variable only one spot. Well, there is no way we can combine the x squared and the x. So there's no way here that we can get down to the variable only appearing once in this problem. So we have to take a different strategy to solve it. And the strategy we took dealt with that zero product rule, where we said if a times b equals 0, then either a is 0 or b is 0 or both. So the first step we needed to do is set this thing equal to 0. So right now it equals 5. To make it equal 0, we have to subtract 5. On the other side, we still have to subtract 5 to keep this equation balanced. Where can we subtract 5 from? The 11. So now we've got x squared plus 5x plus 6. Now the trick would be to see if this can be factored. I'm going to give you a minute in your notes, see if you can. What did we get when we tried to factor that? X plus 3 and x plus 2. Perfect. So what that's telling us, since those two multiply to make 0, either x plus 3 equals 0 or x plus 2 equals 0. And now we have two linear equations we can solve. Two regular equations, I should say. We don't know the term linear yet. Subtracting 3, either x is equal to negative 3, or over here you can subtract 2, x is equal to negative 2. If you were to go on to like a introductory college algebra, actually this is kind of an introductory college algebra course here anyway, intermediate college algebra and so on, we would spend a lot more time solving this type of equation. For this course, we're not going to put a lot of time into it. That's kind of the next step beyond what we're doing. So we're going to step back into equations that are what we call linear equations. When we get into graphing in a few weeks, you'll understand why they're linear. But we can narrow it down to where the variable only appears once, put it that way. And so let's take a big step back to an equation like this. I want you to take a minute, see if you can remember how to solve that in your notes. So the first step here would be to do what? You see parentheses, so we've got to do something there first, which would be multiply by the 8. Good. 8 times 2x is 16x, and 8 times negative 7, negative 56. Good. So from there we would add 56. 16x equals 80, and then divide by 16. X equals 5. We've done simple equations like that before. Well, not so simple, but with simple parentheses. And one of the things that always comes up is, why can't I just divide by the 8 first and make it go away? And get 2x minus 7 equals 3. Well, in this equation, you can. You can divide by 8 and solve it from there. You're going to get the same answer. The reason I don't teach that is because we will run into equations like this. Here we would not be able to just divide by this. Oops, get my 5 back there. Here we would not be able to just divide by this 5 here. It wouldn't work because we've got this piece here. When we are solving equations, if we add or subtract, we only have to do it to one piece on each side. When we multiply or divide, we have to do it to every piece on each side. So if I divide by 5 here, dividing this whole section by 5, I would have to divide that by 5 and that by 5, and that gets confusing. So it's easier to go ahead and do the distributing. Multiply that 5 through the parentheses. So we get 5 times 7x is 35x, and 5 times negative 4, negative 20. Now we do still have the positive 5 here, and that equals 90 yet. Now there's some combining we can do. Anything to combine with the 35x? Say no. No. But we can combine our negative 20 and positive 5 to make negative 15. Now what would we do? Add 15, good. 35x equals 105, and then divide by 35. So x equals 3. In fact, we can step it up even a little bit more. I'm going to have you guys try this one in your notes. Just a little bit different than the one we just did. See if you guys can pick it up. Talk about this one and see what you did. So we start out multiplying by the 5. What is 5 times 3x? 15x. 5 times 1 is 5. And the 2x is still there. What can we combine this time? 15x and 2x, which make 17x. So we've got 17x plus 5 equals 56. What's our next step? Subtract the 5. Good. 17x equals 51, and then divide by 17. X equals 3. Any questions? Okay, well, let's look at one a little bit more difficult. I'm actually going to have you try this one. Kind of combines each of the last two problems with one more little twist to it. I'll give you guys a minute to try that one. Okay. So we're going to start out on the left side, combining what we can. We're going to multiply by the 7. So 7 times 2x is 14x. Good. 7 times 5, 35. We still have the negative 4x. And I'm going to stay on the left side and combine what I can there. What can I combine? 14x and negative 4x make 10x. So I've got 10x plus 35 on the left side. Over to the right side, I've got the parentheses, so I have to work there first. I'll multiply by 5. 5 times 6x, 30x. 5 times negative 3, negative 15. We still got the plus 4. Nothing to combine with the 30x, but negative 15 and positive 4 make negative 11. Now we've got x's on both sides of the equation. We haven't run into that yet tonight. We've got to get it down so that x only appears once. So we have to get rid of one of them. Which one are we going to get rid of? Usually the smaller one, right? So we're going to subtract 10x. So we've got 35 equals 30x minus 10x is 20x minus 11. From there, what do? We'll add 11. So 46 equals 20x. And then divide by the 20. Good. So x is, depending on whether we want this as a decimal or a fraction, as a fraction, we could just divide it out and get 2.3. Or sorry, as a decimal, sorry. You just divide it out and get 2.3. As a fraction, we could have the 46 over 20. I could either reduce it by 2 or I could make it a mixed number. Let's reduce it by 2 first. So that'll be 23 over 10. 10 goes into 23 twice with 3 left over. So 2 3/10. Excuse me. So we've either got 2 3/10 as a fraction or 2.3 as a decimal. Those are the same answer. In my math lab, it may ask for the answer as a decimal or a fraction. You have to put it in that form. On a test, I would take it either way. Okay. Now this next one usually causes some problems. Come on. So we see we've got parentheses here, but when we look at it, it doesn't look like there's anything up here to multiply the parentheses by. There really is, even though we don't see it. And what it is, there's the minus there. And we can think of that as being a negative 1. Just like a lot of times we'll do 7 minus x. What we're really thinking there is that is a negative 1x. Same thing here, minus a parentheses, it's a negative 1 times a parentheses. So the 2x isn't going to change. We have negative 1 times 5x, which is negative 5x. Negative 1 times positive 1 is negative 1. That equals 14. On the left side here, I can combine. What can I combine? 2x and negative 5x make negative 3x. So negative 3x minus 1 equals 14. Then what? Add 1. Negative 3x equals 15. And then divide by negative 3. So x equals negative 5. So again, the important concept there was when we see that minus, that negative in front of the parentheses, we have to treat it as a negative 1 times that parentheses. So I'm going to give you guys one to try in your notes. A little bit different, but the same concept. See if we can get that one to turn out. We'll talk about it in a minute. So we have two sets of parentheses here, so we're going to work from left to right. The first one, got to multiply through by the 2. 2 times 5x is 10x, and 2 times negative 4, negative 8. The second one, again, there's no number out there, but there's that negative, the minus, so we treat that as a negative 1 times the parentheses. Some of you, by the way, may have been taught if you see that minus in front of the parentheses, you just change the sign of everything in the parentheses, which is effectively the same thing. So negative 1 times 3x would be just negative 3x. Negative 1 times 2 is just negative 2, and that equals 4. So now we need to combine stuff over here on the left side. 10x and negative 3x make 7x. Negative 8 and negative 2 make negative 10. What would be our next step? Add 10, good. So 7x equals 14. And then divide by 7, yes. So x equals 2. Now, just like any of these equations, I haven't done it for a couple of classes, but we got x equals 2. That means we can always come back up here and put 2 in where the x is. And this side better come up with the same value as this side of the equation. So this here all better come out to be a 4, and it will. But don't forget that option is there for double checking your equations. Okay, well, I want to step this up just a little bit. Yeah, we'll maybe try a couple more examples here first. 4 times 5x plus 3 minus 2 times 3x minus 4 equals 62. I'm just going to have you guys talk me through this one. What do I need to do first? 4 times 5x is 20x, and then 4 times 3 is 12, good. And next? Negative 2 times 3x is negative 6x, and then negative 2 times negative 4 is positive 8. Then what? Perfect. 20x and negative 6x make 14x, and then 12 and 8 make 20. Perfect. That still equals 6. What's next? Subtract 20. 14x equals 6 minus 20 is a negative 14. And then divide by 14. Good job. X equals negative 1. So let's step this up a notch. I'll have you try that one in your notes. Okay, so here we've got two sets of parentheses on the left side. And we've just got the extra variable on the right side. So we start out multiplying through by the 2. 7 times 2x. 14x. 7 times negative 5. Negative 35. Then we've got the negative 2 here times 3x. Negative 6x. And negative 2 times 1 is negative 2. Now let's combine what we can there. I've got 14x and negative 6x makes 8x. Negative 32 or negative 35 and negative 2 make negative 37. And that equals on the other side, there's nothing to combine, just 3x plus 13. Now, we have an x on each side, so we have to get rid of one. Which one are we going to get rid of? The 3x. Good. Subtract it. So that gives us 5x minus 37 equals 13. And then add 37. So 5x equals 50. And then divide by 5. So x equals 10. One more of these and then we'll switch gears a little bit. Let's take it to the extreme. I'll give you a minute to try that one and then we'll go over it. This one's got some length to it, doesn't it? So we're going to, again, break down the left side first, then the right side. So on the left side, I'm going to multiply by 3. So 3 times 5x is 15x. 3 times negative 1, negative 3. The next parentheses is multiplied by negative 2. So negative 2 times 3x, negative 6x. And negative 2 times 4 is negative 8. I see the yawning and I sympathize with you totally. This feels like one of those nights, doesn't it? Okay, now to combine on the left side here, I've got the 15x and the negative 6x make 9x. Negative 3 and negative 8 make negative 11. On the right side, we'll multiply by the 5. 5 times 2x makes 10x. 5 times 7 makes 35. Good. Multiplying by 2. 2 times x, 2x. And 2 times negative 3, minus 6. And we also have a plus 2 there yet. So combining on the right side, we have 10x and 2x make 12x. Positive 35 and negative 6 make 29, and then plus 2 is plus 31. Now we have to get rid of one of the x's. Which one do we want to get rid of? The 9x. How do we get rid of it? Subtract 9x. We have to subtract it from the other side as well, so we'll subtract from the 12x. This is a negative 11 here. Since it was minus 11, it's a negative 11. 12x minus 9x, 3x plus 31. And then subtract 31. Negative 11 minus 31 is minus 42 equals 3x. And finally, Divide by 3. Negative 42 divided by 3 is a negative 14. X is negative 14. How many of you got that on your own? Good deal. Okay, so this next one is going to be a slightly different flavor to it. We've added in our fractions a little bit to our equations already. We've seen ones like this, x over 3 plus x over 2 equals 15. And the way we solved it was we treated x over 3 as 1/3 x over 2 is 1/2 x, equals 15. And then we combined 1/3 x plus 1/2 x. Well, 1/3 plus 1/2 is 5/6. So that's 5/6 x equals 15. And then, of course, what would we do to solve that? We would divide by 5/6. So x equals, well, 15 over 1 divided by 5 over 6 becomes 15 over 1 times 6 over 5. Cross canceling the 15 and 5 gives me 1 and 3. 3 times 6 is 18. 1 times 1 is 1. So x equals 18. But there is another way we could have done that. We could have done a least common denominator. Now remember, a least common denominator is the same as a least common multiple, only we're looking at the denominators of a fraction. So this one, x over 3 plus x over 2 equals 15. What is, first of all, we have to identify what are our denominators here. We've got 3 and 2, right? So for 3 and 2, what is the least common denominator or least common multiple for those? 6, yes. What we're going to do with that least common denominator is we are going to multiply this whole equation by that least common denominator of 6. So 6 times x over 3. Let's write this out. 6 over 1 times x over 3. That's 6x over 3, or divides out to be 2x. 6 times x over 2. We'll write that as 6 over 1 times x over 2. 6 times x is 6x. 1 times 2 is 2. So that's 6x over 2, which divides out to be 3x. Then, of course, we got 6 times 15 on the other side, which is just 90. Now the fractions are gone. That least common denominator, the purpose of doing is it eliminates the fractions. So eliminating the fractions turns it into a simpler equation to solve. Here then, of course, to solve that, we would add 2x and 3x to get 5x equals 90, and we would divide by 5 to get x equals 18, which is the same answer we had before. Now in this equation, it's about the same amount of work to work with the fractions as it is to do this least common denominator. It may be less confusing to work with the fractions. Same would go in this next equation. There. We could just work with the fractions. What would be our first step if we were just going to solve this? We would add the 3/4 to both sides. So 1/2 x equals, well, 6 1/3 plus 3/4 We're going to have to change that into twelfths. So 1/3 is 4/12. 3/4 is 9/12. That's 13/12, or 1 1/12. So we keep the 1/12, carry the 1s, that's 7. So this is 7 1/12 here. And then we can divide by the 1/2. Gives us x equals 14 1/6. Or we can take that and apply this least common denominator to it. Since it is break time, we're going to leave that problem up there for you to think about, and we'll work on it after break. Let's take 10 minutes. It is 4:20. Let's come back at 4:30. Go ahead and get rolling here. So if we were to try to solve this same equation using least common denominators, we have denominators of 2, 4, and 3. So for 2, 4, and 3, we need to find the least common multiple. What's the smallest number that all of those would go into? 12. Good. So we are going to multiply this whole equation by 12, every piece of it. So 12 times 1/2 x, 12 over 1 times, now it's easier here if we write that 1/2 x as x over 2. That becomes 12x over 2, which reduces to just 6x. Then we've got the 12 times the negative 3/4. So 12 over 1 times, I'm going to put the negative 3, the negative with the 3 on top. 12 times negative 3 is a negative 36. 1 times 4 is 4. Negative 36 divided by 4 is a negative 9. And finally, we have 12 times 6 1/3. So 12 over 1 times 6 1/3 is going to become 19 over 3. That is 221 over 3, which divides out to be, what, 76? I did something wrong there. 12 times 19 is not 221. It is 228. So that divides out to be 76. And of course, now we can go ahead and add 9. So 6x equals 85. And we can divide by 6. X equals, we're going to take that 85 over 6, and we're just going to reduce it like it's an improper fraction. 6 goes into 85. 6 goes into 8 once. That's 6. Bring down the 2. Bring down our 5. 6 goes into 25 4 times would be 24 with 1 left over. So 14 1/6. So we get the same answer, and there's a case where it might actually be easier to use those least common denominators. Well, the reason I'm showing you that least common denominator, that method, is because there are some equations where we have no choice. For example, an equation might look like this. Here, the variable, the x, is in the denominator. So the only way to solve this is to use a least common denominator to get rid of those fractions. So my denominators here are x, 4, and 3x. The x here I'm going to think of as being a 1x. So what that means is I just have 1, 4, and 3 for numbers. So I'm basically just 4 and 3. What's the least common denominator for 4 and 3? 12. And then for variables, I have to take the highest power of the variable. So it's just going to be x. So what's going to happen is I'm going to multiply this whole equation by 12x. So what's 12x times 5? 60x, right? Next, we're going to do 12x times 3 over x. So this will be 12x over 1 times 3 over x. 12x times 3 is 36x. 1 times x is x. 36x divided by x is just 36. Now we have the 12x times 1/4. So 12x over 1 times 1 over 4. 12x times 1 is 12x. 1 times 4 is 4. 12x over 4 is just a positive 3x. Or 12x divided by 4 is positive 3x. On the other side now, we still got to multiply by the 12x. 12x times 1 over 3x. So 12x over 1 times 1 over 3x. 12x times 1 is 12x. 1 times 3x is 3x. 12 divided by 3 is 4, and the x's divide out. So now we're at this equation here, which we know how to solve. What would we do first? Combine the 3x and the 60x make 63x. We still have plus 36 equals 4. Then what? We will subtract 36. So 63x. 4 minus 36 is a negative 32. Our final step. Divide by 63. X equals, now you could divide that out and get a decimal, or you could just leave it as a negative 32 over 63. Any questions? Let's look at one more example of that. So let's say I've got 4 plus 6 over x plus 2 over 5 equals 11 over 2x. Tell me what to do. We have denominators, right? What are they? x5 and 2x. What will our least common denominator be? 10. Then for the variables, x. Remember, it's the highest power. So I'm going to multiply this whole thing by 10x. 10x times 4 is 40x. 10x times 6 over x. 10x over 1 times 6 over x. 10x times 6 is 60x. 1 times x is x. Well, that just divides out the x, so we're left with a plus 60. 10x times 2/5. 10x over 1 times 2 over 5. 10x times 2 is 20x. 1 times 5 is 5. 20x divided by 5, 4x. And then finally, 10x times 11 over 2x. So 10x over 1 times 11 over 2x. 10x times 11 is 110x. 1 times 2x is 2x. That divides out. 110 divided by 2 is 55. The x's divide out. What's our next step here? 40x and 4 make 44x. Plus 60 equals 55. And then we subtract 60. 44x equals a negative 5. And then divide by 44. X equals negative 5/44. We've been getting some pretty ugly answers. I'm going to have you guys try one in your notes. Three-fourths plus 2 over x plus 1/5 equals 7 over 2x. Have you tried that one? And we'll talk about it in just a minute. Or a couple. Okay. So what is our greatest common or least common denominator here? Will the 4 and 5 make it 20, right? X. So 20x times 3/4. 20x over 1 times 3 over 4. 20x times 3 is 60x. 1 times 4 is 4. 60x divided by 4 is 15x. 20x times 2 over x. 20x over 1 times 2 over x. 20x times 2 is 40x. 1 times x is x. 40x divided by x is just 40. 20x times 1/5. 20x over 1 times 1 over 5. 20x times 1 is just 20x. 1 times 5 is 5. 20x divided by 5 is just 4x. On the other side, 20x times 7 over 2x. 20x over 1 times 7 over 2x. 20x times 7 is 140x. 1 times 2x is 2x. 140 divided by 2 is 70. X's divide out. What's our next step? Combine like terms. Good. 15x and 4x make 19x. Plus 40 equals 70. And then subtract the 40. 19x equals 30. And then divide by 19. Good. X equals 30 over 19, which is 1 11/19. Any questions? Okay. So a couple more examples of different things, and then we're going to call it a night here. Now we look at this equation, and we see the 7x, the x squareds in it. And we think we might have to go back to that method we talked about at the beginning of this class where we got it equal to 0 and factored. But as we go through and combine what we have here, we've got the 7x squared minus 3x plus 7. And we are subtracting the 7x squared goes under the x squared. The negative 4 is going to go under the 1s. 7 minus a negative 4 is 7 plus 4, which is a positive 11. Well, negative 3x minus nothing is just negative 3x. Well, 7x squared minus 7x squared cancels out. So that equals 7. Now, again, some of you may have been taught you just change the sign of everything in this parentheses and then combine like terms, you'll get the same result. But the key is the x squared disappears. And now this is just a linear equation to solve. What do you have to do? Subtract 11. Negative 3x equals 7 minus 11 is negative 4. And now to solve, we're going to divide by -3. X equals, well, -4 divided by -3 is a positive. Negative divided by negative. 4/3, or 1 1/3. Another variation of that might look like this. So again, here we see that x squared, and we worry that we're going to have to do that factoring and solving. But when we go to try to combine them, we subtract 27x squared from one side, we subtract 27x squared from the other side, and once again the x squared cancels out and disappears. So we've got -3x plus 11 equals 2x minus 19. What are we going to do next here? Yes, we still have an x on both sides, so we get rid of the smaller one, which is the -3x. We get rid of it by adding. So that's 11. The -3 is gone. 2x plus 3x is 5x minus 19. Then what do? Add 19. So 30 equals 5x, and then divide by 5. 6 equals x. Okay, that's pretty much all the new material today. There's more examples I could do, but my face is pounding, so let's call it good enough for now. There is a new quiz that is due tomorrow, Friday, at 11:59 p.m. And there is a new homework that'll be due next Tuesday at class time. You guys have a good weekend.